More in reducing fractions, but we're going to use prime numbers. Who remembers what a prime number is? Remember when I gave you the blocks and I said, okay, here's 7 blocks. See how many rectangles you can make. You have to use all 7 in each rectangle. And there is one rectangle. What are the factors of that rectangle? 1 and 7, right? Can you make another rectangle out of that 7? No, because it doesn't work. So if you can only make one rectangle, or if the factors are just 1 in itself, you have a prime number. Okay, so 7 is a prime number. Let's think about what numbers are prime. We're not going to worry about number 1. Let's start with number 2. Do you think 2 is a prime number?
Yes.
What are the factors of 2? 1 and 2. And they're going to make one rectangle. So 2 is prime. How about 3? Yes. How about 4? No, because you can make 2 times 2 and 1 times 4. How about 5?
Yes.
Okay. How about 6? No, 2 times 3 or 1 times 6. How about 7? Yeah, we just figured that out. How about 8?
No.
You know, really no even numbers would ever be prime, right? Besides 2, because they're always going to have 2 times something. So 8 won't be. How about 9? No, because you got 3 times 3, right? 10? No, because you got, that's even. How about 11?
Yes.
Yeah, okay. So you can have some fun if you want and figure them out, but most of the ones we're going to use are pretty small. Now we're going to take a number like this, 12, and we're going to take 18, and I want you to find all the prime numbers in there. And I'm going to do it by building a tree. What times what will give you 12?
3 times 6.
3 times 4, right?
Yes.
Okay, is this prime?
Yes.
Okay, we can stop there. Is this prime?
No.
So are there any more factors in 4? Yeah, 2 times 2, right? Okay. So all the prime factors of 12 are, well, we're going to put these, we'll put them over here, 2 times 2 times 3. How about 18? Any factors of 18? What do you know? 6 times 3? This is already prime. How about this?
Nope, it's got 3 and 3 in it.
That's 2 times 3, right? So the prime factors of 18 are 2 times 3 times 3. All right?
Yep.
Now, there's another way you can do it, and it's called repeated division. And you could take the 12, for example, and you could put the 12 here. What do you want to divide by 12? Into 12? 2? 2 into 12 is what?
6.
6. Then we do it again. What goes into 6?
2.
2. What do you get? 3. And there's your 3 factors. See? 2, 2, and 3. So either way will work. All right, now the reason that you're doing this is, again, so you can reduce or decrease a fraction. So if you had 2 denominators, one was 12 and one was 18, what could we divide out of both of them? They both have a 3 in them, right? They both have a 2 in them. So if we had this fraction, 12/18, which is the same as 2 times 2 times 3, and this is the same as 2 times 3 times 3. What does this line mean? Divided by. What's 3 divided by 3? 1. What's 2 divided by 2? 1. So that's the same as 2/3, right?
Yes.
Sometimes we even put little ones up here, like that. Okay, so let me look about one more thing here. 12 divided by 18, or 12/18, is the same as 2/3 because we can reduce them, right? By doing prime factorization. That's what this is called, prime factorizations. Okay, let's try another one. 10/14. Now we got a couple ways we could do this. The first thing we could do is look at it and say, what do those things have in common?
They're both even.
Both even. And then we could divide them both by 2. And we get 5/7, right? That's one method. With this method, we're going to take the 10. What are the factors? 2 and 5. How about 14? 2 and 7. So this is the same as, where's my little eraser? This is the same as 2 times 5. This is the same as 2 times 7. What's 2 divided by 2? 1. So the answer is 5/7. Okay? So you've got another method now for reducing fractions. Either look for the greatest common factor, or do prime factorizations and divide numbers, numerator and denominator, the same. Okay.